Welcome to the screencast of 5.4. So this is about sum and difference identities. One thing I want you to notice right off the bat is that when you have sine of alpha plus or minus beta, that's going to be equal to sine of alpha, cosine beta, and then plus or minus cosine alpha sine beta. So what this means is, if you have sine of alpha plus beta, you'll have sine alpha cosine beta plus cosine alpha sine beta, right? So the pluses go together, the minuses go together. But you don't necessarily have to worry about that because I'm going to let you use the equation sheet. And then you also have cosine of alpha plus or minus beta. This is equal to cosine alpha cosine beta minus or plus sine alpha sine beta. So notice I wrote it in a different order. This means that if I have cosine of alpha plus beta, it corresponds to cosine alpha cosine beta minus sine alpha sine beta. So that's what I'm just trying to point out to you, is if I have a minus inside with my cosine, a plus here. Similarly, if I have a plus cosine, I will have a minus out here. So it's opposite, but you just have to make sure that when you use your equation sheet, you actually copy it over correctly. So this is if I have an angle that's not one I already know. So for instance, the angles that we know are 0, 30, 45, 60, 90. All the other angles are iterations of these. We'll use all of these angles as reference angles and we can figure out what the actual are later. 0 pi, pi over 6, pi over 4, pi over 3, pi over 2, and of course 180 is pi, 270 is 3 pi over 2, 2 pi is 360, etc., etc. But what if I have something like example 1a? Sine of 75 degrees. I don't entirely, I could guess and I'll be close, but I don't know the value of sine 75. But I can rewrite this as sine of 30 degrees plus 45. Because 30 plus 45 is equal to 70. So let's see. I'm going to say my alpha is 30 degrees. My beta is 45. And I'm going to use, let me write this. Sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Cool. So I'm going to go ahead, I'm going to use this. Every time I see an alpha, I'm going to plug it in 30. Every time I see beta, I'm going to plug in 45. So I have sine 30 cosine 45 plus cosine 30 sine 45 degrees. So I know sine of 30 degrees is 1/2 multiplied by cosine 45 square root 2 over 2 plus cosine 30 is square root 3 over 2 times sine of 45 square root 2 over 2. If you don't understand how to get these angles, make sure to come in to bonus and I can show you. So I'll show you the first one, 30, 60, 90. Here's 30 degrees, cross is 1/2, and then I have square root 3 over 2, and here's 60. So honestly, you should know the unit circle by now. Sine of 30, so katoa, it's opposite over hypotenuse, so that's opposite of 1/2 over hypotenuse 1. Cosine 45 square root 2 over 2, hopefully you understand that one. And cosine of 30 is adjacent over hypotenuse, so adjacent is square root of 3 over 2 over 1 hypotenuse. Cool. So let's multiply these top. 1 times square root of 2 is square root of 2 over 2 times 2, 4. I have 3 times the square root of 3 times square root of 2, so that's going to be square root of 6 over 2 times 2 is 4. So I can rewrite this as square root of 2 plus square root of 6 all over 4. Awesome. So let's keep going to the next one. So I want to write this as a sum of angles. You can go ahead, pause the video, try it out yourself. Keep in mind, we only really know 5 angles: 0, pi over 6, pi over 4, pi over 3, and pi over 2. So maybe I can try out one of them. For instance, what if I want to try out pi over 3? So I know pi over 3, another way to say that, is going to be 4 pi over 12. So if I do 11 minus 4, I'll have 7 pi over 12. That doesn't work. So that's not going to be one of my angles. However, I can try 4 pi. 4 pi is the same thing as 3 pi over 12. If I do 11 pi minus 3, I get 8 pi over 12. And 8 pi over 12 can be simplified to 2 pi over 3. And we know that angle. So we know that angle because it's a multiple of 60 degrees. 60 degrees is pi over 3. And so this is going to be an angle of 120, which is what we know. So let's see. This is equal to tangent of pi over 4 plus 2 pi over 3. So I'm going to have this be my alpha plus beta. All right. So over here we have the tan sum identity. So I can go ahead and plug in. So this is equal to, let's see, tangent of alpha, so it's pi over 4, plus tangent of beta, 2 pi over 3, over 1 minus tangent pi over 4 times tangent 2 pi over 3. So it'd be a lot easier to plug in if I knew what the values were. So the value for pi over 4, so let's think about this. So I know tangent, TOA, here's pi over 4. Oops. So what will my values be for pi over 4? So this is 45, 45, 90. So that means my two sides are square root of 2 over 2 and square root of 2 over 2. So if I do opposite over adjacent, tangent of pi over 4 is going to equal square root of 2 over 2 over square root of 2 over 2. Since I have the same thing on top and bottom, tangent of pi over 4 is equal to 1. That makes sense. At 45 degrees, my x and my y, my cosine, my sine, are the same value. Alright, so wherever it says tangent pi over 4, I'll plug in 1. I also need to figure out what tangent of 2 pi over 3 is. So 2 pi over 3, let's see. So 2 pi over 3 looks something like this. That's the angle. But I'm going to use the reference angle, which is going to be pi over 3. So this is 60 degree angle, pi over 3 is 60 degrees. Across from 60, square root of 3 over 2. Of course, this is a 30 degree. Across from that is 1/2. So tangent is opposite over adjacent, and I'm looking at the 60 degree angle. So opposite, square root of 3 over 2, divided by adjacent, 1 over 2. The 2's cancel out. It's like I'm multiplying by the reciprocal, 2 over 1. Except, let's see, all students take calculus. Tangent's going to be negative in this quadrant. So tangent of 2 pi over 3 is going to equal negative square root of 3. So now we know the values to plug in. So this is equal to 1 plus negative square root of 3 over 1 minus 1 times negative square root of 3. It's equal to 1 minus square root of 3 over, let's see, negative times negative 1 plus square root of 3. Cool. So we're done with this one. An alternating current I in amps in a certain circuit can be found after t seconds using I equals 4 sine 255t. So this is just a rando equation. But the reason I include it is because we can rewrite this as a formula in terms of a sum of two angle measures, which is what we're going to do in part A. So I is going to equal 4 times sine of 255. So I could try 180, right? Because 180 I know that's pi, but then I'll have 180 and pi. Or I'll have 180 and 75. I don't know 75. I mean, I just found it, but I want to only use angle measures I know. So let's see. I could use 210 and 45. Because 210, it has a 30-degree reference angle. Because 210 is going to be 30 degrees past 180. So the reference angle would be 30, so you know that one. Or we could use 180 plus 445. Let's see, plus 45 is 225. And 30 degrees. So you know 30 degrees. Let's double check. 225 would be here. Yes, that'd be a 45-degree reference angle. It's 45 degrees past 180, and you could figure that out. I'm just going to go with the first one that I wrote down. So let's go with 210 degrees plus 45 degrees. Oh, times t. Don't forget that little t. Awesome. Use a sum identity to find the exact current after 1 second. So I'm going to plug in 1 for t. So don't forget, I'm like using this equation still. So 4, I'm going to put in my 1 because that's my t. And then I need to use the sum identity. So this is going to equal, let's see, addition of signs. So sine 210 times cosine 45. And I'm adding, so it'll be plus, cosine 210 sine 45. And I know each of these values. So 4 times, let's see, sine of 210. Sine of 210. So it will look like this. It'll be 30 degrees more than 180. Let's see, this is 90, 60, square 3 over 2, 1. Okay, cool. So the reason I drew it like this is because I'm going to be in my third quadrant. All students take calculus. Cool. So sine of 210. This goes to 80 and this 180 and that's 210. Cool. Sine of 210. Sine opposite over hypotenuse. So 1/2 over 1 is going to be 1/2 times cosine 45 square root 2 over 2 plus cosine of 210. So cosine of this guy. Cos is adjacent over hypotenuse, so that's going to be square root of 3 over 2. And then sine of 45 square root of 2 over 2. Okay, let's make sure I wrote everything correct. Issue is, when I did my sine of 210, I didn't take into account the fact that sine is negative in the third quadrant. So I need to add a negative sign. Negative. Because sine, my y is negative in third quadrant. Cosine is also negative in third quadrant. Because my x is negative in third quadrant. Alright, I am ready to simplify. So negative 1 times square root 2 is negative square root 2 over 4. 2 times 2 is 4. Minus, because there's a negative, square root of 3 times square root of 2 is square root of 6 over 4. Now, if I distribute out this 4, I would get negative 4 square root 2 over 4 minus 4 square root 6 over 4. 4's cancel out. Get negative square root 2 minus 6 square root 6. That's it. Now we want to find the exact value of tangent, let's see. I want to find the exact value of tangent 78 degrees minus tangent 18 degrees over 1 plus tangent 78 degrees, tangent 18 degrees. Oh my gosh. So really what we're doing here is we're going to go the opposite direction. We're going to condense it. Because before we've been taking a sum of two angle measures and using a sum identity to expand it out. But here we're going to do the opposite direction. We're going to condense it. So this whole thing. If you look at your identities, let's see, it has to be this guy. This whole thing. I can rewrite it as tangent of 78 minus 18, right? Because alpha was 78, beta was 18, so I can rewrite it at the bottom. So this whole thing is equal to tangent of alpha minus beta. 78 degrees minus 18 degrees. So that's equal to tangent of 60 degrees. Well, sweet. We know that is equal to square root of 3. Done, done, done. In case we don't understand why it's square root of 3, I'll go through it. Feel free to skip ahead. 60 degrees. This must be 30, so across from 30 is a half. Square root of 3 over 2, 1. Okay, cool. Drew my triangle. TOA, opposite, square root of 3 over 2, over adjacent, 1/2. Dividing by a half is the same thing as multiplying by 2 over 1. So that guy's gone. 2 goes away, and I have square root of 3. Awesome. We're really flying through this. So now we want to simplify sine pi over 3 plus times cosine pi over 4 plus cosine pi over 3 times sine of pi over 4. Oh my gosh, check it out. We have this plus sine cosine. So this is going to be sine of alpha plus beta, because notice the plus here, plus in the middle. So this is the same thing as saying sine of pi over 3 plus pi over 4. That's the same thing as saying, well, let's see, common denominator will be 12, so multiply by 4 over 4, multiply by 3 over 3, so it's going to be sine of 4 pi over 12 plus 3 pi over 12. Same thing as saying sine of 7 pi over 12. Done. It's a lot easier, I feel like, going the opposite direction, condensing. You don't have to write as much, you're literally writing less. Alright, so this next one is not as nice. It's kind of ugly, not gonna lie. Sorry this screencast is a little long, but this is literally took us 2 days to do section 4. Alright, so let's look closer here. So I have right cosine of arc sine square root of 3 over 2 plus arc cosine x. Let me make this whole first part be alpha, and let me make this whole other part, the second part, be beta. So then I have, let's see, then I basically have cosine of alpha plus beta. So I know that's going to be cosine alpha, cosine beta, minus sine alpha, sine beta. Alright, so now I know how to plug in. Alright, so every time I see alpha, plug in arc sine square root of 3 over 2. Okay, so I have cosine of alpha, cosine of arc sine square root of 3 over 2 times cosine of beta. So that's arc cosine x minus, let's see, sine alpha, which is arc sine square root of 3 over 2 times sine of beta, so it's going to be times sine of arc cosine x. Alright, so we remember from 4.6 that if I do, remember that arc cos is the same thing as saying cosine to -1. We also remember that if I do cosine to -1, aka the inverse, to cosine of x, that's equal to x. They will literally cancel each other out. They will cancel each other out. So let's look close. So I know cosine, arc cosine cancels each other out. Sine, arc sine cancels each other out. So this term goes to x minus this term goes to square root of 3 over 2. Now, with the two easy parts done, we need to figure out what this guy is. So here, this part literally is saying For what x is sine equal to square root of 3 over 2? That's what it means. So for what x is sine of x equal to square root of 3 over 2? So the angle, let's see, SOHCAHTOA, opposite, square root of 3 over 2 over hypotenuse 1. So what angle is this? Oh, we see it's going to be 60 degrees, which is pi over 3. Okay, so now I could plug that in place, and I can ask, okay, so what is cosine of pi over 3? So cosine, so I know this is 60 degrees. This angle here, or write this is pi over 3. So cosine's adjacent over hypotenuse, so that's 1/2 over 1. So it's just a half. So this guy goes to 1/2. My other side, let's see. So sine of arc cosine x. So I need to draw a triangle. Here's theta. So cosine is adjacent x over hypotenuse 1. If I want to figure out the length of this side, I can do a squared plus b squared equals c squared. So a squared, Pythagorean identity, plus b squared equals c squared. So that's x squared plus b squared equals 1 squared. So minus b squared on minus x squared on both sides. B squared equals, well, 1 squared is just 1 minus x squared. So now this side length is going to be b, is going to be the square root of 1 minus x squared. So since we can't, since we're like trying to add and subtract these terms, you can't square root them alone. Like this is not equal to 1 minus x, it's 1 minus x squared. Okay, so that's what we filled out the triangle. So now if I want to do sine of this angle, let's see what it would be. So sine, SOHCAHTOA, sine of this angle would be opposite square root of 1 minus x squared over 1. So we know that this value should be square root of 1 minus x squared. Okay, now that we found each part, let's combine. So I have 1/2 x minus square root of 3 over 2 times the square root of 1 minus x squared. I know that's equal to x over 2 minus square root of 3, square root of 1 minus x squared over 2. And that's equal to x minus square root of 3, square root of 1 minus x squared. I'm just rewriting everything over 2. Check, check, done. Sweet. All right, so we're almost done. The next two are relatively quick and easy and fast. So let's verify cosine of negative theta equals cosine of theta. So aka, we are going to prove we recognize that negative theta is the same thing as saying 0 minus theta. So I can rewrite this in saying cosine of 0 minus theta should equal cosine theta. Now don't forget, cosine of alpha minus beta is equal to cosine alpha, cosine beta. Oh, this is minus, so it's going to be plus sine alpha, sine beta. All right, so let's plug in. So I have cosine 0, cosine theta plus sine 0, oops, sine 0, sine theta. All right, so from a unit circle, let's see, 1, 0. See, so cosine of 0 is 1, remember that's the x, times cosine theta plus sine of 0 is 0 times sine theta. 1 times cosine theta is just cosine theta. 0 times sine theta is 0. And then we found cosine theta equals cosine theta. Yay! Okay. Feel free to pause the video as much as you want. Come into bonus. You got this. You're doing great. Example 7. Verify cosine of theta minus pi over 2 equals sine theta. Okay, so I already have the identity laid out for you. It's right here. This is the identity we're going to use. Here's alpha minus beta. Alpha is theta. Beta is going to be pi over 2. Notice that even though we have a subtraction sign right here, I'm not actually saying it's a negative beta, right? So the subtraction's part of the formula, not part of the angle. All right, so I'm going to have, let me just plug into identity, cosine theta, cosine pi over 2. This is a minus, so it's going to be plus, sine theta, sine pi over 2. Trying to prove this is equal to sine. Cosine theta times cosine pi over 2. Right here, cosine pi over 2. 0, 1. So cosine is going to be 0 plus sine theta. Sine of pi over 2 is positive 1. 0 times cosine, 0. Sine of theta times 1, sine of theta. So we prove 0 plus sine theta is just sine of theta is equal to sine of theta. Check, check. Awesome. All right, lastly, solve. Cosine of pi over 3 plus x plus cosine of pi over 3 minus x equals a half over the interval 0 to 2 pi. So when it says over the interval 0 to 2 pi, that means we do not have to add. We do not have to add the plus 2 pi in. Whew. All right, so first thing I'm going to do, I'm going to expand this guy out. So I have, let's see, cosine pi over 3, cosine x, minus sine pi over 3 sine x, plus cosine pi over 3 cosine x. Let's see, this is a minus, so it would be plus. Okay, plus sine pi over 3 sine x. And this is going to equal 1/2. So let's figure out what cosine and sine of pi over 3 are so we can plug in, because this is a lot of numbers. This is unfortunate. Okay, so pi over 3. Pi over 3 is equal to 60 degrees. Check it out, 30, 60, 90 triangle. Sweet. So, cosine pi over 2, cosine of pi over 3 is going to be, well, pi over 3 is 60. So cosine adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent 1/2 over hypotenuse 1 will be 1/2. Oops, sine of pi over 3. So katoa, so it's going to be sine is opposite square root of 3 over 2 over 1, so it's just square 3 over 2. Okay, so now we know these values to plug in. So cosine pi over 3 is 1/2 cosine x minus square root 3 over 2 sine x plus cosine cosine of pi over 3 1/2 cosine x plus, let's see, sine pi over 3 is square root of 3 over 2 sine x equals 1/2. Okay, plugged in values. Now let's try to combine some like terms. So right here, I see 1/2 cosine x plus 1/2 cosine x is just going to be cosine x. It's like 1/2 plus 1/2 is 1. So 1 cosine x, and then minus square root 3 over 2 sine x plus square root 3 over 2 sine square x. They go away. It's kind of like having minus 3 and plus 3. They go away. All right. Let's see. So, and this is going to equal 1/2. All right, it's carrying this over. So cosine of x equals 1/2. So where am I looking at? All students take calculus. Where is cosine equal to 1/2? Well, I'll have a positive and I'll have a negative. Here's my, I'm sorry, when I say negative, I mean fourth quadrant. Whew. Both of these places, cosine is equal to 0. Oh my god. Cosine is positive. Cosine is positive in both these quadrants. So what angle is this? Let's see. Cosine, adjacent, 1/2, over hypotenuse 1. Wait, hold the phone. This is a 30, 60, 90. So check it out. My angle is 60 degrees, also known as pi over 3. But I'm going to have another angle as well. So I'm also going to have the angle. So I have this one, pi over 3, but I also have the one that goes all the way around to here. So to find this angle, I'm going to do 2 pi minus pi over 3. Let's see, get it over the same. So it's 6 pi over 3 minus pi over 3, 5 pi over 3. Yep. I'm a third less than 2 pi. Cool, so that's it. And I don't have to find for all values, it's just over the interval from 0 to 2 pi. So here's all the homework questions. I already posted the solutions on Haiku. Let me know if you have any questions.